Indonesia is known as one of the countries in the non-largest sugarcane production in the world, with a total of 28.9 million tons in 2020, Food and Agriculture Organization.
Production in Indonesia amounted to 21 million tons in 2007, so the potential for coal to be produced is around 6 million tons per year.
Bigas or Saccharum officinarum is a fibrous waste materials for sugarcane stems that has undergone safe extraction in the sugar processing industry. Bigas contains 44 until 52.7% cellulose, hemicellulose 20%, and 24.2% lignin.
Fibers and water hyacinths as materials for making plywood.
The hyacinths or Ihornia chrysops is a plant that lives in waters such as swims and lakes. Water hyacinth has chemical components such as 60% cellulose, 8% hemicellulose, and 70% lignin. Water hyacinth is known as a weed due to its uncontrolled growth.
If the sugarcane and water hyacinth waste is not processed properly, it will cause things that are not cool in the surrounding environment, such as environmental pollution, natural disasters such as flood, and so on.
Therefore, researchers made plywood from bigas and water hyacinths.
Plywood is a composite that is generally made of wood, given the global action plan agreed upon by the government, namely programs related to the 2030 SDGs. One of the goals in Indonesian SDGs number 15 is to protect terrestrial ecosystem with forest management programs and prevent biological conservation.
Assalamualaikum warahmatullahi wabarakatuh. Move together, build our nation.
Hello young scientists and all judges of Indonesian Science Project Olympiad 2023. My name is Dea Maulina Zukhrufa, and then my partner.
My name is Shira Narda Nawafa, and we are from
Islamic State Senior High School, Kudus.
On this occasion, we would like to present our scientific research project under the title
The Potential of Bigas and Water Hyacinth Stem Waste as Materials for Making Plywood to Support SDGs 2030.
Based on the background, we want to know about how the composition and the level of effectiveness of bigas fibers and water hyacinths as materials for making plywood.
Based on the background, the purposes of our research is to determine the composition and level of effectiveness of bigas fibers and water hyacinth stem as materials for making plywood.
Our research wasn't experimental.
We started by preparing tools and materials. The bigas and water hyacinth stalks were sorted and cleaned, then cut into small pieces with a size of 2 until 5 centimeters.
The fibers was taken from each, after which it was dried in the oven. After drying, the two basic ingredients were measured using a blender and sifted to produce fine particles.
The fine particles were mixed with water and urea formaldehyde adhesive at a concentration of 0.83%, 0.37%, and 0.26% of the dry weight of the raw material, respectively.
Next, the result of density test from the plywood composite. The density test is carried out by calculating the density of each composite part, and the data is obtained. In the density test, the lowest variation was indicated by the third variation with a value of 0.040 gram per cubic centimeter.
In the next test, namely the water content test, the results obtained are variations 2 and 3 that meet the standard value for water content set by ISPO 5908/2003, which is 5 until 13%. In variation 2, it has a water content value of 6.21%, and in variation 3, it is 5.96%.
The third test performed was the thickness expansion test. It was found that the lowest thickness expansion value was in variation 3, which was negative 0.68%. Subianto 2003 states that the thickness development is directly proportional to the density. This is in accordance with the data obtained.
It can be seen that the higher the downside value, the higher the thickness expansion value. With this in mind, it can be concluded that the three variations of the composite board have met the ISPO 5908/2003 standard regarding the specific thickness development value, namely a maximum of 12%.
The next test is the impact test. The result of this test shows that the variation that has the highest impact strength is variation 3 of 7.19 kJ per square meter. This is because this variation is one that has more fibrous content than the other variations. So variation 3 can absorb more energy, whereas in variation 2 it has an impact test value of 6.99 kJ per square meter.
And in variation 1, it is 3.91 kJ per square meter.
Based on the research, we can make conclusions.
Based on the results of the density test, moisture content test, and thickness swelling test in variation 1, it has a density of 0.5 gram per cubic centimeter, a moisture content of 4.80%, and a thickness expansion of negative 0.91%. Variation 2 has a density of 0.49 gram per cubic centimeter, a moisture content of 6.21%, and a thickness expansion of negative 0.84%. Variation 3 has a density of 0.40 gram per cubic centimeter, a moisture content of 5.96%, and a thick expansion is negative 0.68%.
Based on the impact test of the mechanical properties of bagasse plywood and water-hyacinth stem fibers in variation 1 is 3.91 kJ per square meter, variation 2 is 6.99 kJ per square meter, and variation 3 is 7.16 kJ per square meter.
That's all the results of our scientific research project.
Thanks for the attention.
Wassalamualaikum warahmatullahi wabarakatuh.